10 itself, 10 meter. In the tabular column, how you will fill, students? You will be filling the tabular column here 10 meter, capital D. Then gratings line per millimeter. For example, I can make it as, you can put your own value, students. 400. I'm making it as 400. I'm able to see only 2 spots. I want to take 3 orders. And the wavelength I want to keep 650. 655 I have put. I am getting only one order. So what I will do, I will try to bring 3 orders. Yes. Now 3 orders are there. Typically, what is a model reading? I'm putting the lens to grating at 10 meter. Capital N. Now the number of lines per meter is 224. And the wavelength I have used is 655. You are free to select your, yes, please.
This class is not being recorded, sir.
Yeah, 1 minute, I will record it.
Chat la solluங்க.
Thank you for the intimation. I will record it.
Chat la.
Yeah, even Shifa Sahani. Okay, thank you both of you. I will record the meeting. Okay, students, I will put all the recordings by tomorrow for the first 2 units. So actually I told students there are 2 ways of doing. This is one way. So first we will do this way, at least for one reading we will stay online in phase. Now what is the distance between the grating and the screen, students? 10 meter. So here in the tabular column, first row, what I will write, 10 meter means 1000 centimeter. So my first reading is 1000 centimeter. You can take your own value, students. You need not do for 10 only. You can do for 9.5. Just vary and see, students. What is happening, you will able to know better. You vary and see. Now let me put it as there's some problem with the system. You can just vary the distance, students. You can vary and see what is happening for 6, what is happening for 8. But throughout the experiment now, it must be 224. Okay. Once I fix this, you should not vary grating lines per millimeter. You should not vary the wavelength. You should only vary the lens to grating distance. So better to check first whether you are getting 3 orders. Yeah, I am getting 3 orders always. I am getting more than 3 orders. So now the first reading is 1000. Then order of diffraction 1. Now what is x1? X1 is d1. Okay, in tabular column it is given as x1. It is same as small d1 which I told yesterday. Small d1 is how much? This is 0, minus 1, minus 1.5. Lower end is minus 1.4. You can take it as 1.5 itself. So what is x1? 1.5. What is tan theta? 1.5 by 1000. From that you will find out theta. Tan inverse 1.5 by 1000. Then I go to the right side. Again on the right side the same reading, 1.5. This is 9.85. Okay, it changed as 9.85. So 985. So 1.5, 9.85 meter. 9.85 means 985 centimeter. So 1.5 by 985 is going to be tan theta. Theta will be tan inverse 1.5 by 985. From that I will find out average of theta 1 and theta 2. From that we will find out sin theta, capital N, you already know, 224 lines per millimeter, converted to meter. Then small n is 1. In tabular column it is not clear. It should be sin theta by capital N into small n. For first horizontal row, small n is 1. Then you will take n as 2, then as 3. So all of you please calculate your first reading and put in chat box, students. What is the wavelength you are
Sir.
selecting? Yes.
Sir, you kept the wavelength as 655 now, sir. Is it necessary that we too must keep it as the same wavelength, or
No,
we
you can choose
change the
anything, Ashok
wavelength?
Kumar. You can choose 650, you can choose 640. Yes. You can choose 680, 690. Please
Yes. So
select
once we
any
selected
value
it, it must
between,
be kept as
preferably
constant.
between 6. Yes. Throughout the tabular column, it must be constant. And all the 15 readings must be closely to 655 now.
Okay, sir.
Is it okay, Ashok?
Yes, sir.
You can
Sir,
select
can you
anything.
choose-
Even you can select 620. Yes,
Sir?
yes, student. Someone is speaking. I'm not. Yes, yes. Please go ahead, ma.
Sir, can we choose capital as n as any value, sir, as a fixed value? Not
Any
only.
value. You can take any value. Not only 224. The only condition is I must get 3 orders.
Okay, sir.
You can select 300. You can select 150. You can select 400. 3 orders must be there. That's all.
Okay, sir.
Sir, but in the
But
tabular
once we
column they have
select,
given for
yes, yes. Go ahead.
in the tabular column they have given for first order, second order, third order, no, sir. So is it not necessary that we
Yes.
must change the value of n to correspondingly to change the value of the order of diffraction
No,
in
no.
this,
See,
sir?
see. N is fixed. Are you able to see my screen now?
Yes, sir.
Are you able to see my screen? First order
Yes,
is
sir.
1.5. Second order is how much? This is 0. This is minus 3. So second order
Oh,
is
okay, okay,
D2
sir.
is 3.
Okay, sir.
X2 is 3. Same
Okay, sir.
value of
Understood now.
capital D. Third order is minus 4.8.
Yes, sir.
Is it
Got it
okay,
now.
Ashok? Yeah. Yes,
Yes, sir.
yes.
Got it.
All of you, please do one reading, students, and first put it in the chat box. What is the wavelength you are selecting? Here I have selected 655. By calculation, how much I am getting? Both must be compatible. How much you are selecting? 655 nanometer. Same range you must get. If not, you put your readings, share your readings. I will see what is wrong. So go ahead with the first reading, students. Once you get the first reading, you will get everything. Today
So totally
60.
how much readings would we take, sir?
For every distance, you will take 3 readings.
Sir,
First
how
order,
much distances we should consider, sir?
5 distances.
Okay, sir.
So 5 into 3, totally 15 readings.
Okay, sir.
Sir, in the
Those who are
table
doing
6
it
is given,
mobile,
so we must just omit the 6.
yes, Ashok.
In the table they have given for 6 readings, sir. So
No need, no need. You do
is it
for 5.
okay
It's enough.
to just okay, sir.
No, for 5 is enough. 5 is more than enough. 15 you will get. That in actually when you do in the lab, what we will do is see, we will select how to select the distance. Also, I am saying 0 to 3 to 10. Okay. So we will select one far distance 10 meter, you will select one short distance, 3 meter. You will select one value between 3 and the center, 7.5. For example, 5. Then you will select another value between 7.5 and 10. For example, 8.5. So uniformly you will select from the minimum of the scale to the maximum of the scale. Between 3 and 10, you can equally take 5 readings. Short distance, long distance. Now 60 are there and I'm having 2 logins, so 58. As I call each and every one, let me know students whether you are having mobile or whether you are having laptop or system. If you are having mobile students, 10 readings are sufficient. 2 into 5. Is it clear students? Those who are doing with mobile, 2 into 5, 10 readings is sufficient.
Sir, up to how much decimal places we should consider, sir?
Which decimal space? Distance, tan theta, when you are doing tan theta.
Yes, sir.
2 decimal places.
When we are finding theta, sir?
Yes, 2. 2 is sufficient.
Okay, sir.
It will be a number. Whether you put tan of the number or tan in angle, it will be almost same value. But better you convert it into degree. I think all of you know how to convert it into degree in your calculator. Just press the 3 dots